Alright, before we've used the remainder theorem and the factor theorem, here we're going to couple that with our rational zero test, and this is going to help us find some of our zeros whenever we are not given a factor or we're not given an actual zero to start with. So whenever we use our rational zero test, this is where we do our old faithful, the P over Q. So a possible rational zero could either be a fraction or an integer, and fractions could be written as decimals, but we'll deal with fractions here. P and Q don't have any common factors, and P is a factor of the constant term, so that would be your last number. This is where you get P from. And then Q is going to end up being a factor of your leading coefficient. So if we start off with whatever number here is here in front, this is your Q. So you're going to find factors of P over Q. So for example 7, if we had to find our rational zeros, that means we have to have integers and fractions. We need to find our rational zeros of f of x equals x to the third plus x plus 1. So your P over Q that you're going to start off with is going to be your factors of your constant term at the end, so factors of 1, and we're going to divide that by the factors of your leading coefficient, which is 1 also. So if you list out your factors on top of 1, well, that's going to be a plus or minus 1, and then your factors of 1 on the bottom is going to be another plus or minus 1, so that means if you group together your factors on top of the factors on the bottom, well, if you take a plus 1 on top paired up with a plus 1 on the bottom, that means you're going to have a possible factor of 1. If you take the 1 divided by, or the negative 1 divided by 1, that means you're going to get a negative 1. So these are your two possible factors. Now what are you going to do with these two, these would be your two possible zeros. So once we find these, we have to plug these into our synthetic division. So we're going to plug a 1 in. And remember, we're going to use our remainder theorem where we need to get a 0 with the synthetic division. And if we do get a 0 by our factor theorem, that means that x plus 1 or x minus 1 would be a factor. So we're going to bring down the 1 in front of x to the third. We have a 0 in front of our x squared. We have a 1 in front of our x and another 1. So you bring down the first term. Bring down the 1. And you have a 1. So that gives you a 1 on the bottom. 1 times 1 is 1. So 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. And you have a remainder of 3. Well, if you get a remainder of 3, that means 1 is not a 0. So then we'd have to try negative 1. So you plug in negative 1. And we bring down 1, 0, 1, 1. Bring down the 1 at the beginning. So you have a 1. 1 times negative 1 is negative 1. So 0 plus minus 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2, which is negative 1. Now once again we find out that our 0 is not equal to 1. Sorry, I meant that if your remainder is not 0, that means that negative 1 is not a 0 either. So if you find out that you don't have any zeros, well then this problem, the x cubed plus x plus 1, does not have any rational zeros. So there are no rational zeros. This is rare that this happens, but it does occur. So if you maybe look at the picture of your graph, find out that this does not have a nice pretty little fraction or integral 0 at either 1 at 1 or at -1. So if you don't have a 0 here or there, then that means this is not going to be a rational 0.